Algebra 2. We're going to start the semester final guide study guide. Final exam study guide. Okay, start with radicals. Now remember, when you add radicals, you can only add radicals if the inside of the radical, called a radicand, is identical. Okay, and then you just add the coefficients. So you got to know what those words mean. It means then that this guy right here has a radicand of 5, but these guys have a radicand of 3. So it means we can combine these two, but we can't combine the third. So he's just going to tag along at the end of our simplification. So adding these two together is not a problem. That is just 5 radical 3. But notice what happened. The 2 and the 3 just added together, but the radicals stayed the same. Don't make it any more complex than you need to. It's just that simple. All right, now we're going to subtract 3 radical 5, and those guys cannot combine. I know you think you can, but they're different. This is radical 3, that is radical 5. Entirely different numbers, okay? Now over here, you'll notice that we've got 3 radical 2. He is his own thing. He does not have a radical 2 to combine with, but these guys are 2 radical 3s. So that's a radical 3, that's a radical 3. Add those together, and 2 minus 1 is just 1. So that is a positive 1 radical 3. Now just leave it like this. There's nowhere for it to go. You just leave it, okay? That is a radical 2, that is a radical 3, done. Now this right here, now these two are definitely going to combine. That's negative, so it will stay negative because they're both radical 6s. But that 54, though, I'm a little worried that I could simplify this. Let's see if I can. Inside 54 is a 9 and a 6 when you multiply. And when I have a 9, I've got 2 3s. So it looks like I can take out a pair of 3s and then have a 6 left over. So if I take a pair of 3s out, it's going to get multiplied to the negative 2 that's already on the outside. So that's negative 6 radical 6. Okay, so that's great because now these two guys are also negative 3 radical 6, negative 3 radical 6. Now you might be thinking that all these guys cancel each other out, but they're all negative. So what we do is we just keep moving to the left on the number line, and so that is going to be a negative 12 radical 6. Okay. Now there's this, there's nowhere else to go. Okay, 6 has a 2 and a 3, and both of those are prime numbers. There's no pairs to take out. Okay. All right. Now with this one, now you would think that these guys, I would just multiply and be done, and that is true. That I can multiply them because they're both radicands if, oh wait, I skipped this one. Before I get to that, I just get so excited. So here we get okay, radical 2. This guy is an 8, so I could combine those, but inside 8 I know is a pair of 4s. So 8 is 4 times 2, and inside 2 is a 2 and a 2. So looks like a pair of 2s are coming out. So that is negative 2 radical 2 minus radical 2 minus 2 radical 2. So these 3 right here are these 3 here. Now I do have this 27, and inside 27 is a pair of 3s. So it's 3 times 9. So now I got, okay, I could take out a pair of 3s here, and there's already a negative 3 there, so that would become negative 9 radical 3. Now this guy's not going to combine with anyone, so he's going to be part of your final answer, but I can combine those. I've got negative 2, negative 1 together, that's negative 3 radical 2, with 2 more, still negative 5 radical 2. So my final answer is negative 9 radical 3 minus 5 radical 2. Okay. All right, so moving back to here. Now, I am multiplying now. Multiplying means that I can combine the two radicals together easily. I'm not adding, though. I am multiplying, but radical to radical, you can combine them, okay? It's not like this. Here you had to make them the same in order to combine. These you don't, okay? So I could have written it like this. okay, and broke down 15, because now you can see that's 9 times 5. I can take a pair of 3's out and leave the 5. Your answer is going to look like this, okay? Radical 45 is the same as 3 radical 5. Okay, now that's kind of one of the easier ones. Here, you're going to have to distribute because you are... Now, I'm not going to throw a bunch of these at you. I'm just going to throw a couple. 1 addition, subtraction, 1 multiplication. You know, this is just some practice because this is back farther in the past, so I wanted to make sure that you had enough to practice this and no surprises on the exam. But there's not going to be a lot of this, okay? So there's going to be more of what you have at the end. And as Emily pointed out, there are some typos that I'm going to address in those eventually. Okay, so so negative 2 times distributed to here is radical 6. So notice that I can do 2 times 3. I can do that. Negative 2 times, there's basically an invisible 1. You can look at it like that. Negative 2 times 1 is just negative 2. Now I'm going to distribute it here, and I get negative 2 times 4, which is negative 8. And then radical 2 times radical 2 is radical 4. Now the square root of 4 is 2. So this means that I've got negative 8 times 2. So that's negative 2 radical 6 minus 16. All right, and there's nowhere to go from here because now we're doing something like this. Okay, we're subtracting, and those guys have to have the same radical in order to combine them. All right, now with this one, we've got 2 binomials. So here we're going to be distributing just like here, but we're going to be doing it twice. So this guy goes to here, and then this guy will go to here and here. So that's 4 multiplication situations. Okay, so here we get negative 4 radical 4, because radical 2 times radical 2 is just radical 4. And then we're going to get negative 4 times 3, which is minus 12, but then the radical 2 just stays the same because 3 does not have a radical to multiply to the radical 2. Then I move to the inners. Okay, 3 times radical 2 is, you guessed it, 3 radical 2. They just squeeze together. And then 3 times 3 is just 9. Okay, now this guy right here, radical 4 is 2, so negative 4 times 2 is negative 8. So negative 8 and 9 will combine. Those you can add together easily. You did that in the first grade. So now, or maybe kindergarten, so that's 1. Okay, so one of your answers, you'll have 1. And then these two both have a radical 2, so just like up here, we could combine them. We can combine these. That's negative 9 radical 2, because negative 12 plus 3 is negative 9. So negative 9 radical 2. That is your final answer. Okay, same thing's going to happen here. Now you've got a total of 4 square roots being multiplied. This is pretty much as hard as it gets. And you're just going to multiply the inners with the inners, outies with the outies. Okay, coefficients with coefficients, radicands with radicands. All right. So radical 5 times radical 5. Oh, but that's negative, though. So that's going to be a negative radical 25, which is 5. Okay, so that's this. Now I'm going here. Negative 3 times positive 1 is just negative 3, but then radical 5 times radical 2 is radical 10. Radical 3 times negative radical 5 is negative radical 15, which does not simplify, by the way. And then you've got this guy times this guy, which is negative 3 radical 6. Now, pause for a second, and if you did not well, don't pause yet, because then you'll never hear this comment. But what I want you to do is just try to recognize where the numbers are coming from and why they are what they are, okay? There's really no other way to explain it other than saying keep the radicands with the radicands, the coefficients with the coefficients, okay? None of these guys can combine. These are all done. This is your final answer, actually, okay? All the radicals now are different, okay? He doesn't even have one. So these guys are all different, and when they're different, you cannot add or subtract them, okay? Okay, where are we at? 10-minute mark? All right, let's stop.